Hey devs, welcome back. My name is Rob, and this is episode 1 of the Developer's Guide on launching your own NFT collectible. I didn't forget about you guys. Sorry it's taken me a bit to get this video out. It's been about a week. I think what I'm going to try and do is set up these developer videos to come out on Fridays. That way, you guys can watch the video, take what you've learned, and apply it on your project over the weekend, compared to doing it during the work week or something if you've got a full-time job or whatever. Um, the goal of this video is to cover the whole process from a developer standpoint. Just in general, I'm not going to go into too much detail, but I want to give you enough information that the people who know how to solve problems only need to watch this video. You won't have to watch the in-depth stuff on how I'm actually running things. But I will show you a little bit of code here. I was originally going to do a PowerPoint, but everybody hates PowerPoints, myself included, and I work for the government, so I'm going to see plenty of PowerPoints this weekend. So let's just jump right into it. The process I like to break down into 4 components. The smart contract. Oh geez, I can't do that with my fingers. The smart contract, the image generation, the website, and the connections. And by connections, I mean IPFS and your API, as well as a slight adjustment you have to make to your smart contract once it's published. So we'll start with the smart contract. Right here, I have my sassy succulent one. And like I told you in the first video in the disclaimers, I'm not going to beat around the bush. The way people do their smart contract is they find a project that they like. There was 2 or 3, maybe 10, 20 really good developers out there that made some smart contracts. But there's thousands of NFTs. So what most people do is they find a project they really liked. Maybe you were part of the community and you were there for launch and the launch went really smooth. So, the contract is probably pretty decent. Or maybe you minted something from their contract and, gas was $15 for an NFT. I know EtherGirls kind of set that standard with theirs. I'll try and link something down in the description. They have a thread that kind of explains how they did that. But what you're going to do is find a smart contract you like for whatever reason, and you're going to use that as a guide. You're going to use it as a guide. You're not going to copy it, but use it as a guide for building your own. And as you can see on here, I'm at the bottom of my smart contract. But I've got 1,674 lines of code above where my relevant content starts. The rest of this is my contract. So I have about 100 lines of code that is actually mine. The rest of this is Open Zeppelin standard. If you've never heard that term before, Open Zeppelin is the ERC 721 standard. It's a giant library of really useful stuff for making NFTs. I combined all of their libraries that I used. I combined them into one file, which I know in general is really bad practice. I get that. And a lot of people like to reference them as separate files. And so when you look at their contract page, they're going to have, their contract that's 100 lines of code, and then it's going to have 12 other files in there. I didn't do that because that's a huge pain in the ass. So I just combined them all into one. But if you look here, it's not a complicated contract. I've got some variables up top. I've got a few functions for reserving tokens, one for minting. I've got this one called set base URI, which we'll talk about later in this video and later on down the road. Withdrawals, and just a search function here. So your smart contract is not a lot of work, and it's not really detailed. So you got to develop one of those. You got to deploy it, and you need to verify it on Etherscan so that you can interact with it. Once you've got your smart contract done, you can move into, or this is not a set order, but this is just how I'm going to talk about them. Disregard, if I tell you that you got to do one before the other, just disregard that. Let me pull up VS Code here. So we can move into image generation. If you look at my file explorer on the left here, I've got, this is all of the code for my whole project, and you can find this on GitHub. Uh, I've got the contract up here, I've got my website, and I've got this folder called Sassy Gen. This is my Sassy Succulent image generation. And there's not a lot to this either. It's kind of misleading because it's got a lot of folders and stuff. But really all this is one file, one Python script that uses a library called Pillow or Pill. And again, it's not a lot of work. What you got to do is find all of your traits that you want. I call these attributes, and I call these ones inside here traits. So I will try my best to refer to them as such, but I kind of get them mixed up every once in a while. So you've got your different attributes here. This is going to be, you know, your face or the hats or the backgrounds or whatever. Just those different things you can categorize together. For mine, it was like the plants and the pots and the faces and the backgrounds, stuff like that. And for each one of these, you are going to have a separate trait file. If you look over here on the File Explorer, I've got underneath trait layers, I've got a bunch of different folders. I've got my backgrounds, my buddies, my faces, pets, plants, etc. And each one of these has the different options. Now these different options are just, they're just image files where everything is placed in the exact same spot. If you can see, I'm going to cycle through a couple of these here. If you can see, let me scroll down. I can't scroll down. Classic. Sorry about that. Still can't see. Son of a bitch. How about now? Okay. If you can see on these, all of the bases of these plants end at the exact same spot. It's all about right here. And there is a reason for this. It's because this image generation works by taking a bunch of different attributes, each having their own image, and you just stack the different layers on top of each other and then compose it into one image. So all of your different layers need to line up perfectly. This is where your dev is going to have to interact with your artist the most. May not seem obvious, but as you run into problems, you're gonna need to talk with them on how you're gonna handle all of this stuff. And when you finally start generating the image, you know, you're probably gonna run into problems with things not lining up perfectly, and you've got to talk to your artist about how that works. But the script is not too hard. Again, we'll go over it later in a different video, but you've pretty much just got a list of your names here. These are what are going to show up on OpenSea. And you've got a list of your rarities, right? One per thing, adding up to 100. And then you've got the actual file names of all of your shit. So it's pretty easy to associate these two dictionaries together. These are Python dictionaries. Well, these are, sorry, not these arrays up here. But you go through and you pick a couple, you pick one trait from each attribute and you compose it into, you know, whatever you want to call it. In my case, I called it new image, but it's just an array. And you toss it in a giant collection up here, whatever data structure you want. Again, mine's just an array. And that's how your image generation works. You know, you can adjust how many you want, stuff like that. And down here I've got a section that verifies they're all unique, adds the token ID to them. This one's really important. And I've got a little part down here that counts all of the outputs. You know, I've got, for this background Bespin, I've got 398. That just happens to be the rarest background, in case you're wondering. Um, and then you take that giant array and turn it into um, what's called your metadata. You just output it as a giant JSON file that's going to be served from your website. Um, and finally, your images or your attributes are already picked. All you got to do is pull in your image files and compose them on top of each other. On top of each other to make that single image. Um, so that's your image generation. It's really straightforward. Let me switch back to the browser. The next step is your website. Um, your website really only needs one to two things. If you're planning on doing website minting, which seems to be the most popular option, you're going to need a place where you can mint. For mine, I have a separate page. If it ever loads, I have a separate page where you can just interact with the smart contract. Super basic, not a lot to it. A lot of people throw this on their main page in the form of like a little section or something. You can do whatever you want to integrate it. And you just need some information about your project. So in general, people like to put links here on how they can actually buy one, links to the socials, some information about your project, and a lot of people throw a roadmap up and pictures of the teams. I don't have pictures of my teams. And I've got some charity stuff down here because my proceeds are going to charity. If I can ever get proceeds. I've got this third page here that is for beginners because I was planning on marketing mine to people who would donate to charity. I thought this would be helpful. It's helpful for newbies. It really just walks you through how to mint one. Not a lot to it. This is obviously not required for your project, but you know, we're on the site. I figured I'd explain it. So that's your website. This is probably the most time-consuming part of the whole process, just because, at least for me, because I'm not. I have some experience with web development, but I'm not a professional. So this took a lot of adjusting. If you remember back to the other videos, I had someone recommend that I change the background because the background made it hard to read, and I couldn't agree more. It took me forever to get a background where you could even slightly read it. And he just suggested I use one of the ones from the actual images. So great idea. Thank you for the tip. This is another example of how we can all learn from each other. I think this looks a hell of a lot better than it did. And finally, we've got our connection step. The connection step has three components. First of all, you've got IPFS. IPFS is a giant decentralized database. We'll talk about it more in depth when we get to that section, but in general, it's really just a giant decentralized database. Excuse me. And everything is found with what's called an IPFS hash. That's because IPFS works not on where things are, but what they are. So when you give it something like the image that you're going to use for your NFT, it hashes it all up and creates a big long string of unreadable garbage that you are going to, it'll tell things, you know, whatever's looking for it, where to find your image. So all of your images need to be uploaded to IPFS. That part is it's the most complicated. It's not difficult by any means, but it's the most complicated and it has the least amount of information. So we'll talk about that a lot more in depth later. But what you're going to do is upload all your images to IPFS, collect all of the hashes, and append it to your metadata. So let's switch back over here to VS Code. And I've got a file up here called metadata. Yeah, I've got all traits and final traits and hashes. These are examples of hashes of all of my, sorry about that, of all of my images stored on IPFS. All you need to do is collect these hashes, which nobody tells you how to do, um, and append them to your existing metadata. So when all of my image generation is done, this is the metadata that pops out. I've got, my attributes and my token ID, but it doesn't tell you where to find anything. So you have to take those IPFS hashes and add them to your metadata. Um, and that's how websites like OpenSea figure out where your image is, pretty much. Um, so everything's got to get uploaded like that. The second step is to tell websites like OpenSea where to find your stuff. You do this you do this by interacting with your contract, because your contract contains something called set base URI. It's an ERC 721 standard, so regardless of how you build your contract, you should have access to this function or something similar. I'm waiting for this to load, but what you want to do is go over to your contract page once it's all verified, and you are going to set the base URI to a place on your website where where markets like OpenSea can find the information. For mine, it is sassysucculents.co.vercel, because that's what I'm hosting on, /API/ and then whatever you put after this second slash here is going to return something, because I have an API that reads this metadata and feeds it to an application. And that's the last step, is that API. So again, sorry, I'm jumping back and forth, but last step is the API, which I can find in my website because it's part of my website. I've got a little folder here called API, and it takes, the reason I got it in brackets is because it takes an argument. And all it does is takes the argument, say it's token ID number 1 or something, and it literally just searches the JSON file for the token ID, and it pulls the information, and it formats it in the format that OpenSea wants their data in. There's an OpenSea standard for this. Other websites might do it differently. So if you're doing like a Solana contract, you'll have to adhere to their standards on how they want their metadata served. But in general, this is how you do it for OpenSea. You just give them all the information they want, and when they ping your website, you'll just serve this to them, and that's how they pull stuff into the final product you see on OpenSea. So if I go over to my OpenSea page here, and I click on one of my NFTs, you've got all of these properties on the left here, and this is just that stuff you saw in the metadata. And I can prove this to you because we can go to our API, and if I type in, I'm already here, but if I type in API/1, it will serve me the information for token ID number 1, which is what we got here on OpenSea. So you can verify this, right? It's got our image IPFS URL here, and this is where it pulls the image from. It's got our attributes that you can also verify. We've got our background with a value of shooting star. If we go over here, that's excuse me again, that's this background here. I decided to call it shooting star because I got a shooting star in the background. Makes sense. And that's how it's done. I mean, you can do this for any one of the things. So it's not too hard of a process. I'm hoping that this video can be really educational for you guys. If you're a really good problem solver, or if you pause the video a lot, you can just look at the code because I showed you most of it, and you should be able to get all of this done with that. If you're struggling a little bit more, or you actually care about the rest of the series where I go in depth about it, you can stick around. But if not, I think this is enough for most people to go off of. And that was the goal of this video. So thank you so much for sticking around. I will see you soon.